Guys, today I am going to explain you how you can find the relationship between the dependent and independent variable in machine learning. So this is very important topic in ML field because every time we need to find the relationship between the dependent variable and independent variable. In such way we can predict that okay which independent variable which is the most used or which is the high importance than the other one. So let me overview about the my data set. So my data set is like we have three column. Let's consider one example here. So I am the owner of the electric shop. So I have like I am selling like TV, radio, and newspaper, and based on that sale, it's predict something. So my this is my previous data. So my TV sale is around like 230.1. My radio sales is around 37.8, and my newspaper sales is around 69.2. And based on that, my overall sale is like 21.1, which is the actual like previous past data which my shop contain. So we want to predict the sales, right? Okay, so if the which one we want to let me we want to understand that which category like radio, newspaper, or TV is important for me to increase my sales. So I can focus on that only one category. So how we can find that category? So based on our data. So we will explain you today that. So let me go you through the like the we need to find the relationship between the dependent and independent variable in machine learning. So because we need to like okay because everyone should earn the money, right? So that's why in that way we can find out that okay this independent variable is affecting my dependent variable or predicting output more. So that we need to find the which one is the high priority independent variable in my data set. So finding that out, we have one concept which is called correlationship. So here you can see here I have just put the one line. So green line will showing that the correlationship value between the -1 to 1. So this is the like the correlationship value we can always predict using the mathematical formula. We will show you how we can predict that, but let's understand this with the help of this prediction output example. So if my correlationship value is negative between like -1 to 0, something like that. Okay, here if you can see my graph or you can see my cursor, the box is between like this value. So if the correlationship value is between this box like this -1 up to 0, not a 0 exactly, but like the 0.5 or 0.4, you can set up this range based on your data. So I will set up one range which is like the 0.3 or 0.4. I will set up like 0.4. So here I have like -0.4, right? So and here also in the positive way also I am setting up this range. So you can like vary your range based on your data, but I am less explaining or set up the my range. So here if I value between -1 to -0.4, then my relationship is like the negative correlation. If my value between -0.4 to 0.4, then my relationship will be like no correlation. There is no affecting like positive or negative way. There is no correlation. And if my value is from the 0.4 to 1, then we can say it's a positive correlation. So what is the positive, what is no correlation, what is the negative correlation? We can explain that. If let me explain with the help of here. So if we have x and we have x and let's tend to be predict the y, right? So I want to decide that what is my correlation here. If that the positive correlation, then if my x is increasing, then my y is also increasing. Means my means my dependent variable which already I know. X is like the value of x is here like TV, radio, newspaper, anything like three all are the x value, x1, x2, and x3, and sales is my the y value which is predicted value. So here if my x is increasing and y is also increasing, then it is a positive correlation. if my x is tends to y, we can say, and if it's a negative correlationship, I want to explain that. Then we would consider that if my s is increasing, then my y is decreasing. That's the negative correlation. Means if you want to say that, okay, if my x value is increasing and corresponding y value is decreasing, then we can say it's a negative correlation, right? And positive is like x increasing, y increasing, both are increasing, so that's why the positive correlation. And when the no correlation happen is like when there is no difference or no affecting this x and y value. So it's the correlation value in mathematical way, if it approaches to the zero, then there is the no correlation. Means there is the no any dependency between x and y, no dependency between x and y. So that's the we can say no correlation. So here I will explain you like how we can find the correlation and all. So here we explain that, okay, if my value is, I just decide that range like my -1 to minus 0.4, and also in the positive correlation is like the 0.4 to 1. So if that value is present in between the box, then this is the like negative correlation. If my value is present inside this box, then we can say it's a positive correlation. If the value is present in the outside of this box, not negative one or not the positive one, then we can say it's a no correlation. So here the correlation is concept, I hope it's clear, right? So now we can see like how mathematical way we can find the correlation and how we can know that mathematical way, not based on the logic but based on the actual mathematical formulas. So which variable is important for us and which variable is not important for us. So here let me convert this in markdown page. So here we can see that. So here I have the data set. I have already explained that. So okay, I have data set like TV, radio, and which contain lots of columns. So let me here like put the shape here. We can say we have 200 rows and 4 columns: TV, radio, newspaper, and sales. So I want to find the which variable is more affecting my sales, right? So we can say like we can find this using the correlation function. Correlation is the mathematical function. That's the beauty of Python and that's the beauty of pandas. So it will calculate everything for me. No need to go mathematical, put the formula. So here we can we got the correlation, right? So here you can see that my TV, radio, newspaper, and sales. TV, radio, newspaper, and sales. This is diagonal correlation because TV and with TV there is the always be the positive correlation, means higher correlation, because these are the two equal variables. So you can see there is the diagonal matrix which is 1 1 1 1. We can ignore that. So here you can see that the relationship between my sales and TV, you can see there 0.78, right? Then again relationship between the radio and sales is like a 0.57, and relationship between newspaper and sales is like 0.2. So what we can say after the seeing this data, right, based on our diagram. So we can say that, okay, 0.7 means it's in between our like 0.7 here, in between here, like 0. In this positive correlation we can say positive correlation box plot which are present here, So my 0.4, let me here like put here my 0.7 is present here, right? So then again we can say that 0.5, right? So my 0.5 also present in my positive box, 0.5, yes, right. And my 0.2, let's say 0.2 is present in my like here in between something. So here I just drag this one and put here 0.2 something like here, right? So please sorry for this diagram is not looking as much familiar, but let's understand the core concept behind that, because this concept is very important in terms of learning the machine learning. Because you are the data scientist, you are the data analytics, you are the data science or AI engineer, everything. You need to find the correlation between the variables. So in that way you can actually predict or actually select the input, because here you can see here we have already three inputs and one output, right? But in the real time data we have like thousands or millions of input. So at that time we need to find out, okay, which one should we, because if we take all the millions of input and put it into our algorithm, then this algorithm will be like the garbage in garbage out structure. So for that we need to decide which input should go in my algorithm, which can give me the highest or the high priority output or the quality of output. So for that it's very important to find the correlationship. So here you can see here my 0.2 is aligned between this no correlationship map, right? So there you can see my 0.2 means my newspaper of sales is not affecting very much on my sales, because I am selling the newspaper, right? But newspaper, I am selling the newspaper, and newspaper is not affecting or not boosting my sales as much as like the TV or as like the radio. So here that's the, in the mathematical we found that also there is the like radio and the television. So you can see here my television is like, the value of television is near to 1, right? 0.7 is near to 1 rather than 0.5. So my television, I am selling the television, and television is very important category in my sales, which affecting my sales very much, because if I sell one television then it will increase my sales like lots of time or lots of way rather than radio and newspaper. So my correlation, like my positive correlation is aligned like television is the highest priority item in my selling list. I should be focused on the television more, then I should be focused on the like radio, and then I should little bit focus on the newspaper. So television is booming my sale lots of time higher than the radio and newspaper. So that's why I will focus on that one aspect, which is like television, because television will increasing my sale, overall sale very fastly. So that's why if I want to like I want to set up target about my sale, like I sales should be my 1 million, my sales will be need to be the 1 million, then I will focus very much on the television part rather than the radio. In this mathematical way we found out that, so this is not an assumption, okay, television needs many people using television and something like that, nothing like that. So it's an assumption based on the data we find out that. So here it's a mathematical proof that we find out that, okay, this the which category has the highest value in our cell rather than other one. So that's pretty much, that's the correlation, and I hope this concept will give you, or this video give you some insight how we can find the correlation and why correlation is important in our data structure or day-to-day life as a ML engineer. So that's pretty much from my side. Thank you.